Right, I'm going to dive straight in here. I've got a stinking cold, guys. I'm really sorry. So we're going to get this done quick. We are going to dive straight into what will be the first question on the formative test this week. And the chapter this week is very detailed. The objectives are really to try and get you to appreciate some of the real fundamentals of coding. However, I don't need you to remember any of it. Honestly, I need you to be able to do some very, very specific things, which we'll do now. And if you choose to just do this and not really understand the book, that's absolutely fine. It's there as a resource for you in future. I hope you use it. It will give you some examples that will serve you well. But the real objectives here today are for you to take a piece of code that I've already written and then to source it into another script file and then use it to accomplish a very well defined task. And the task today is associated with genomic data. We're going to look at these FASTA files, which contains sequences of DNA strings. So that is something which will be relevant to all of you at some point, I'm sure. And we're going to simply count the number of times a motif, and by a motif I mean a substring, so like an AAA or an ATG or any length of characters appears in each of those sequences. Right, so I've already created an R project. Here it is. I've already got my genomic data 100.fasta from the example in the book chapter saved into my project. Excuse me. I'm going to start a new script file. Actually, I'm going to start two script files, right? One I'm going to call main. Okay. And another I'm going to call FASTA tools. Tools.r. Actually, I'm going to use an underscore instead of a dash there. What have I done in the book? I think I've used a hyphen. Yeah, let's stay consistent with the book. FASTA tools. Right, so these two files are going to contain some code. And now I'm going to give you everything in this FASTA tools.r. Right? In fact, let's just go and get it from the book. Where is it? Here. So here is a big script file, which is full of functions. Now I've gone through some of these functions in detail in the book. Some of them I haven't. Doesn't matter. We can still use them. Don't need to understand how the functions work. We need to know what they're called and what they return, and importantly, what to pass to them in order to get them to return something. So let's just go back here, and I'm going to paste that in. Okay, make sure you save it. And that's it. I'm going to forget about that for now. Let's go to our main. So this file is going to contain all of our instructional code. Okay, and I'm distinguishing instructional versus functional. All of our really gritty functions and logic are stored within our FASTA tool. It's already been built. So I just need to write a few lines here in order to get the job done. Right, let's just specify what we're trying to do. I want to calculate the average number of times that the motif AAT appears in each sequence within a FASTA file. Okay, and specifically we're going to use this genomic data 100 FASTA. Obviously, if you're completing a formative or summative quiz, that file is going to change. So you're going to get different data depending on your opportunity to try it. Right, so very, very simply, I want to read my FASTA file. Now, as it happens, I have already built a function in my FASTA tools that can read that. So the first thing I need to do here is I need to make sure I can access all of the functions in FASTA tools in my main R. So if I go over to my main, my FASTA tools, you can see actually the first function in here is extract sequences from FASTA. Okay, and that's going to read the lines, check out the sequences, and return those sequences. So to make sure I can access those functions, I need to use this line, source, and then I need to call the file name. Oops. Okay, and I'm going to run it. Now, so I've hit Control and Enter there. What's happened in my right here, I've now got a big list of functions that are available to me after sourcing that file. And you can see the first one in there. Actually, it's not. It's the third one down. Extract mean sequences. If I wanted to see just that function, I can click on it, and it will just give me that call. Actually, it'll take me to a link in that fastertools.r file. So there it is. Let's not worry about what it's doing right now. I just want to, firstly, in fact, let's comment this so we know what we're doing, right? I'm going to read or extract sequences from faster file. I'll do that first, and then I'm going to what am I going to do next? Yeah, I'm going to calculate average, or let's call it mean motif frequency for sequences. Okay, so let's do these two things. Right, so first of all, I'm going to define a new variable called sequences. Okay, and I'm going to use my extract. You can see as I start typing, it'll pop up. I'm just going to hit enter there, and I'm going to give it, it's actually telling me what argument it needs. So it needs the faster file, so it needs this file name now. Okay, now that's going to be in quotation marks genomic underscore data 100.faster. Hit control and enter. Right, and you can see now I've got a load of sequences here. In fact, there's a big vector of 100 of them, which sounds about right. There's 100 sequences in the file. I could actually go and look at that if I wanted to. Here's my sequence file. So I've extracted all of these sequences to a big vector of sequences called sequences, and I've ignored all of my headers for each one. That's what that function's done. I could print it out if I want. Dare I do it? Print. So if you want to be absolutely sure, you can hit print sequences, and there you go. It'll just print out everything you got. Let's forget about that. Right, so now I've got that sequences vector. I can run my calculate mean motif frequency function. Let's do that. I'm actually going to create a variable called mean motif frequency. That is what I'm trying to calculate, right? I'm trying to calculate the mean motif frequency for, in this case, AAT. So I want to know the average number of times that motif occurs in all of my sequences. Okay, so it'll go through each sequence one by one. It'll count how many times AAT occurs, put it into a vector, and at the very end, it'll calculate the mean of that vector. Okay, it's a function, so it starts with an adjective because I've been a good boy, and I've used something that makes sense. So find, no, that's not the right one. Calculate mean motif frequency. It's going to take two arguments this time. It's going to take all of my sequences as a big vector. Stick that in. It's also going to take my motif. Now you can do this in one of two ways. If I don't specify a motif here, it'll default to AAA, but I want it to do AAT. Okay. Control and enter. We'll run that, and it's done it. And I've got an answer, 5.16. Or I can print it out. Mean motif frequency. There you go. So the average number of times that the motif AAT appears in all 100 of my sequences is 5.16. 5.16 is the answer for this faster file. you should be able to update the file name based on what you get in your problem and run this again. And that's it. That should go in the box in your quiz to 2 decimal places, and you should be golden. Good luck with that, right? If you have any questions, your first point of call is the workshop channel on Thursday morning at 9 o'clock. Or, better still, come and say hello. We'll be in the Rendell building in person. I'll be there with the team. You are very, very welcome. If you've got any questions whatsoever, do come and say hello, won't you? All right, good luck, everyone.